Hi guys, welcome back to my channel. So in this tutorial we are going to look at the integral from 0 to pi over 2 of x sine of x, all divided by cosine square x plus 10 cosine x plus 25 dx. So let's solve this integral. Before we dive into this integral, make sure you are supporting my channel by hitting the subscribe button for more engaging and challenging tutorials on integral calculus. So let's solve this integral. So let's first recognize that the denominator here, so we have the denominator cosine square x plus 10 cosine x plus 25. This can be factored into cosine of x, that is, you can complete the squares, cosine x plus 5 all squared. That's how the denominator can be factored. So instead of writing the original integral, we can write it like x sine of x in the numerator divided by cosine of x plus 5 all squared dx. And then here we can do some sort of integration by parts. So let's see whether integration by parts will work here. So D for differentiation and I for integration. I am going to differentiate only x and integrate sine of x divided by cosine of x plus 5 all squared. So this is plus, this is minus. If you differentiate x, you get 1. If you integrate this, we can use a u sub. Can do that here real quick. We can let u to be equal to cosine of x plus 5. So du is going to be negative sine of x dx. So in that case, we are going to get the integral of sine of x dx. That is going to be like du, but you have the negative all over u squared. So we are going to integrate u to the negative 2 du. So that is going to be u to the negative 1 plus negative 2 plus 1, which is negative 1 over negative 1. And that will cancel this negative. So in the end, you are going to left with 1 over u, which is equal to 1 over u is cosine x plus 5. So if you integrate this, we are going to get 1 over cosine of x plus 5. So I can erase this now. So now let's do the simple thing. So you multiply the diagonal terms. Once you multiply the diagonal terms, you don't need to take the integral. If you multiply terms horizontal, then you have to take the integral. So this is our integral. The integral from 0 to pi over 2 of x sine of x all over cosine of x plus 5 all squared dx is going to be multiplying terms horizontal. That is going to be x over cosine of x plus 5. This one, you are done with the integral. You take the integral from 0 to pi over 2 minus, that is this term and this term multiply. You have to take the integral from 0 to pi over 2 of 1 over cosine of x plus 5 dx. So let's take the limit here. Plug in pi over 2 first, over cosine of pi over 2 plus 5. Minus plug in 0, that's going to give you 0. Cosine of 0 is 1, so 0 over 6, that should be 0 in the lower limit. Minus the integral from 0 to pi over 2 of 1 over cosine of x plus 5 dx. This evaluates to what? That is, this is cosine of pi over 2. Cosine of 90 is 0, so the denominator is going to be 5. So in the end, you are going to get pi over 10 for the upper limit, minus 0. So this is going to be minus 0 to pi over 2 of 1 over cosine of x plus 5 dx. With this integral, we are going to use the tangent half angle substitution, or what we call the Weierstrass substitution. So that is the integral from 0 to So the integral from 0 to pi over 2 of 1 over cosine of x plus 5 dx. Here we are going to use the tangent half angle substitution. So here the substitution is that t is equals to the tan of x over 2. We have sine, the substitution for sine, but we don't really need sine here, so we need cosine of x. Cosine of x is 1 minus t squared over 1 plus t squared. And dx is going to be 2 over 1 plus t squared dt. We have sine of x, which is 2t over 1 plus t squared, but we don't really need sine here because there's no sine in the integrand. So let's plug all those values in and hope for the best. What about the change in limits? Now we see that when x here is equal to 0, which is a lower limit, what will be the value of t? T is going to be the tan of x over 2. 0 over 2 is 0, tan of 0 is 0. What about the upper limit? When x is equal to pi over 2, we have t to be equal to tan of pi over 2 over 2. That is tan of pi over 4. So tangent of pi over 4 is 1. That is tan 45. So our limits will change from 0 to 1. So we can now take everything from the x world into the t world. So our integral now becomes an integral from 0 to 1 of 1 all divided by cosine of x plus 5. What is cosine of x? Cosine of x is 1 minus t squared over 1 plus t squared. 1 plus t squared plus 5. That is here. And dx is 2 dt over 1 plus t squared. That is 2 dt over 1 plus t squared. Now let's simplify this one, see what we get. That is going to be integral from 0 to 1 of 1 all over 1 minus t squared plus 5t squared all over 1 plus t squared multiplied by 2 over 1 plus t squared dt. This one simplifies to 2 is constant, can come in front. Integral from 0 to 1 of this one, we can flip this one to be 1 plus t squared all divided by this one is 4t squared plus 6. That is right. Multiplied by 1 over 1 plus t squared. So this and this, that is 4t squared, 1 plus 5, that is 6 dt. 2 integral from 0 to 1. These ones will cancel. You are left with 1 all over. You can factorize 2 out here. This is 2t squared plus 3 dt. And this cancels the 2 in front. At the end, you are getting integral from 0 to 1 of 1 all over 2t squared plus 3 dt. So our task now is to solve this integral. We can rewrite this one to look like the inverse tan integral. So let's do it. So first of all, I have to divide the numerator and the denominator by 2. So I'll have like this: divide the numerator by 2, divide the denominator by 2. Dividing the denominator by 2, we are going to get t squared plus 3 over 2 dt. So this 1/2 is a constant. It can go in front of the integral, and you have 1 all over t squared plus 3 over 2. I can write 3 over 2 as square root of 3 over 2 all squared. And we can use the, so when you have this, can refresh your memory with tan. So when you have the integral of 1 all over x squared plus a squared dx, that is going to be 1 over a, the arctan of x over a plus c. So this our integral is from 0 to 1, from 0 to 1. I'm sorry about that. Yeah, I think they all have them along. Okay, So this our integral now looks like something like this. So it is x squared. Here our variable here is t, and a squared. Our a here is square root of 3 over 2. So we can use this in order to solve this integral. So our integral now becomes 1/2 times 1 over a. Our a here is square root of 3 over 2. So that is 1 over the square root of 3 over 2 times the tan inverse of x over a. Our x here is t over our a. Our a is the square root of 3 over 2, like that. So we are done with the integration. We are going to take the limit from 0 to 1. This one can be written as 1/2 times, this is the square root of 2 over the square root of 3, like that. Tan inverse, when you plug in 1, you are going to get 1 over the square root of 3 over 2. So that is going to be the square root of 2 over the square root of 3. Minus plug in the lower limit. If you plug in the lower limit, tan inverse of 0 is going to be 0, because 0 over this is 0. So in the end, our integral evaluates to 1/2 square root of 2 over square root of 3 tan inverse of the square root of 2 over 3. So that is the value of this integral. But then we will have to subtract that from pi over 10. So this integral we just found to be the value down there. So we are going to subtract that from pi over 10, and that should be the value of our original integral. So our integral is the integral from 0 to pi over 2 of x sine x. Our integral from 0 to pi over 2 of x sine x all over x sine x all over cosine square x plus 10 cosine x plus 25, which is cosine square x plus 10 cosine as 10 cosine of x plus 25 dx. That is pi over 10 minus this value. Pi over 10 minus this integral. And this integral, we just got that to be this. So it's going to be pi over 10 minus 1/2 square root of 2 over square root of 3 tan inverse of the square root of 2 over 3. So in the end, we can simplify this one out, so we can rationalize this. So it's going to be pi over 10 minus 1/2 square root of 2 times square root of 2 over square root of 3 times square root of 2 tan inverse of square root of 2 over 3. So that is going to be pi over 10 minus 1 over the square root of 6 tan inverse of the square root of 2 over 3. So therefore, the integral from 0 to pi over 2 of x sine x all over cosine square x plus 10 cosine of x plus 25 dx is going to be pi over 10 minus 1 over the square root of 6 and the arctan of the square root of 2 over 3. So this is the value of the integral. If you find this helpful, make sure to smash the subscribe button for more engaging tutorials. Thank you so much for watching the video, and I will see you in the next one. Bye bye.